Welcome to Maths for All. I'm Aisling Flynn. This is Algebra 2.8 Inequalities. Okay, so a little bit on inequalities. Firstly, let's revise number sets. So the letter N represents the natural numbers. What are they? They are positive whole numbers, or full numbers, okay, nothing between. N equals 1, 2, 3, 4 and so on, and on the number line here you can see the natural numbers marked using discrete dots. Okay, 1, 2, 3, 4. Second group that we come across are the integers, letter Z. They are positive, negative and 0. Okay, and they are also whole numbers, so no decimals, no fractions, full numbers. There we have Z equals, so it extends into the negative numbers, includes 0, and then it goes on forever in the positive numbers. So it is an infinite or never-ending set, same as natural numbers. On the number line we represent the integers using discrete dots on each of the whole numbers. Real numbers then. Well, real numbers are all numbers positive and negative that we can put on a number line, and we represent the real numbers using a solid line. Again, it's infinite, it goes on forever into the negative and positive directions. Okay, real numbers does include fractions and decimals in between the whole numbers. Okay, so there are the number groups. And then the signs that we're going to come across in inequalities. Well, the word inequality means not equal to, so you don't see the equal sign. We've got greater than points to the right, so the positive side of the number line, less than points to the left. Greater than or equal to. Okay, greater than or equal to, you have that extra line on the symbol, and you also have less than or equal to. Okay, so let's do some examples of graphing inequalities on the number line. Okay, so first, if you're told that x is an element of n and x is greater than 3, so what are the possible values of x? So when you're doing inequalities, there can be many different correct answers for x. We get a range of x values. Okay, so we're told x is a natural number and x is bigger than 3. So that means that x can be 4, 5, 6, 7 and so on. And this is how you would represent that on the number line. So discrete dots on the natural numbers that are bigger than 3. So starting at 4 and going to the right. Okay. Now this one is just slightly different. Again, x is a natural number, but this time it says x is greater than or equal to 3. So how does that look different? Well, this time you can include 3 also. So 3, 4, 5 and so on in the positive direction. What about x is an element of z, so the integers, and x is less than or equal to 3? Okay, so first you ask yourself, can we include 3? And the answer this time is yes, because it has the or equal to part. And it's less than, so to the left, and integers can be 0 or negative also. So we start at 3 and go to the left. Integers are whole numbers, so discrete dots. Now here's one with a real number. X is an element of all, so real numbers greater than or equal to 2. So can we include 2? Yes, we can. So we show that we're beginning at 2 with a solid dot at 2, and then a solid continuous line to the right of 2 for greater than 2. And slightly different, the last one x is a real number, x is greater than 2. So can x be 2 exactly? This time, no, because we don't have the or equal to bit. So it can't be 2, but it could be 2.00001, so slightly bigger, so just after the 2. And we show that on the line by putting an empty circle on 2 and then a solid line to the right. So it indicates that it's not 2 exactly, but it begins just after 2. Okay. Okay, let's try some linear inequalities. So they're inequalities that have x to the power of 1. And by and large, you just treat them exactly like a regular equation. This one says left is less than right. So if you were to take 3 from both sides, well, left is still less than right. If you were to divide the left by 3, well then, and do the same to the right, left is still less than right. So the same rule applies. If you make a change to the left, you do the same to the right. So solving for x, I'm going to take 3 from both sides. And what remains is 3x less than 9 minus 3, which is 6. We divide both sides by 3. And I get x is less than 2. Okay, now I'm going to represent my answer on a number line. Okay, and at this stage I must take into account the other piece of information that was given in the question. X is a natural number. So natural numbers are whole numbers and they're positive. So I can only use these numbers to the right, and x must be less than 2, so it's not 2 exactly, it must be smaller than 2, and a natural number, so the only possible solution in this case is the number 1. So x equals 1. Okay, so before we go to the next example, we have to make a note of this. Okay, so on the number line, we have x and minus x. Okay, they're direct opposites, and what they're a reflection of each other in 0. Okay, so if minus x is less than minus 2 in this example, plus x is greater than plus 2. Okay, so everything here has changed. So the sign on the x, so minus x, changed to plus x. Minus 2 has changed to plus 2, but also the inequality sign has changed from less than to greater than. Okay, so minus x and x are reflections of each other in 0. Okay, now what does that mean for us when we're solving? It means at any stage, if you multiply or divide by a negative, okay, which is what happens here if you're switching from minus x to x. Of course, we'll be doing it on both sides. So if you multiply or divide by a negative, less than goes to greater than goes to less than, and the same for the others with the equal sign, so the sign flips. Okay, so that's important. Otherwise, we're just doing equations as normal, except for the occasion when you multiply or divide by a negative, the inequality sign will flip. Okay, so bear that in mind for our next example. Okay, so our next example is here. We've got 4x plus 3 is greater than or equal to 6x minus 4, and yes, our extra information, x is an element of n. Okay, natural numbers. Okay, so what am I going to do here? Solving for x, I will take 3 from both sides, and I will take 6x from both sides. Okay, and what I'm left with is 4x minus 6x, which is minus 2x, is greater than or equal to minus 4 minus 3 is minus 7. Now, here we go. I'm going to divide by a negative number. I'm going to divide by minus 2 on the left and minus 2 on the right. okay? And so I get positive x, and I get positive 7 over 2, and I've divided by a negative, so my inequality sign switches around, okay? That's because I was changing from negative x to a positive x. And remember, it was x in 0. Okay, so what is 7 over 2? If it helps, you can change that to 3.5 for your number line. Okay, etc. Okay, so x, we're told is a natural number, so we'll be sticking to the positive whole numbers. It must be less than or equal to 3.5. 3.5 is here. Can it be equal to 3.5? No, because it's supposed to be natural, and that's not a whole number. So the natural numbers smaller than 3.5 are 3 and 2 and 1. Okay, they're the only possibilities. So x equals 1, 2 or 3. Here we've got an example with fractions, but remember, we'll just treat it as a regular equation until we can't any longer. Okay, so normally we would try and remove the fractions or the denominators by using multiplication. I can do that. My lowest common denominator is 4, so I'm going to multiply the left by 4 and the right by 4. Okay, now we can use division. 4 divided by 2 is 2, and 4 divided by itself is 1. So what remains for my next go? Well, I have 2 times 5x minus 2 on the left, and I just have 1 times, so 8x plus 10 on the right. Okay, let's multiply that bracket. I get 10x minus 4 greater than 8x plus 10. Let's now solve for x. So I'm going to add 4 to both sides, and I'm going to take that 8x from the right. And what do I have left? On the left I have 10x, take 8x gives me 2x, greater than 10 plus 4 is 14. So divide left and right by 2, and I get x is greater than 7. And extra piece of information, x is an element of or, so what does it look on the number line? So we're greater than 7, so we're going to the right. 3, 4, 5, 6, 7, 8, 9. Can it be equal to 7 exactly? No, it can't, because we don't have the equal sign. So we represent this using an empty circle and a solid line to the right for greater than. They're my possible values of x. So now it's time for you to try it with your quiz and your written exercises. Here's a bit of a glossary of some of the words mentioned.